Good evening all, this is Indra from Pantech eLearning. I welcome you all to my session. Am I audible? So SP Harichandan, good evening. Pamula Parthi Vishal, good evening. Shashank, good evening. Vinil, good evening. Yeah, good evening all. Am I audible? Kader, hi. Anandu, good evening. Ajay Kumar, good evening. Yeah. Am I audible, everyone? Are you able to hear me? Yeah, Kirti, hi. Ajay Kumar, good evening. Partha, thank you for a response. Okay, thank you all for a response. Okay, so today is the first day of our Embedded Systems Arduino Masterclass. So today we are going to learn Introduction to Embedded Systems. So before getting into the topic, let me give you an introduction about our Pantech. So we have started since 2004 and we share our experience of 20 years using this EduTech platform. And we help 10 million students to learn technology in easiest way. And in our Pantech, we have 4 engineering graduates, products and services, 100 plus direct team, direct presence in Tamil Nadu, Karnataka, Telangana and Andhra Pradesh. And we have 350k followers on social media and 10k community members. And also Intel FLK technology partner, custom product design, development boards, online and offline trainings, internship, FDPs and as well as STTPs. And you can get our app in Google Play Store. You can go and download it. We are present in YouTube, LinkedIn, Instagram, Facebook and also in Twitter. So use this link to keep in touch with us. Yeah. So these are the master classes which are available in our e-learning platform. Python programming, advanced Python programming, Python full stack, machine learning, artificial intelligence, data science, Java programming, Java full stack, React JS, web development full stack and embedded systems, IoT using Raspberry Pi, computer vision, image processing using MATLAB, artificial intelligence using MATLAB, MATLAB Simulink, EV design using MATLAB, renewable energy design, Amazon Web Services. And I'm telling you this masterclass about, here we are going to learn 21 days of masterclass. So it is only available on YouTube live classes. You have to invest just 45 minutes daily and then you will become a master of embedded systems. And also you will get your e-certificate after completing your 21 days masterclass. So see, during live sessions, the organizer will provide you the Google form in the live chat. You can go for it and put your attendance in that link. And after completing your 21 days of masterclass, you will get your participation certificate. And in this 21 days of masterclass, what you will learn. So here I provided agenda of 21 days of embedded system using Arduino. So from day 1 to day 21, I have mentioned all the topics here. Okay. So today we are going to learn Introduction of Embedded System. Shall we start the session now? Are you all ready? Shall we move to the today's topic? Please drop your replies in the chat box, please. Are you all ready? You have to present till end of the class. In between the session, the organizer will provide you the attendance link in the chat box. You can go for that link and you can put your attendance in that Google form. So after 3 days, the video will get deleted in the YouTube community. So please try to be active in the live classes. Yeah, okay. So thank you all for the response. Now we can get back to the topic. So today we are going to talk about the introduction to embedded systems. So before that, let me give an overview of embedded system. So see, in our daily life, we have seen so many electronic gadgets and so many electronic equipments. So in which equipments or in which devices embedded systems are used? Or in which devices embedded systems are used, we have to know that, right? So that we have to know. So in personal computer systems, we are not using embedded processor. We are just only using general purpose processor. And if you are seeing television, microwave oven, cameras, washing machines, so in all these equipments we are using embedded system. So before going to the overview of embedded system, let's first know the two basic things. One is embedded and another one is system. So what actually do they mean? Let me tell you that. So see, first, what is a system? Please drop the answers in the chat box. Give me a single line of your understanding. What is a system? Here I have already provided the explanation of system, but I want to know about your understanding of what is a system. You can drop the answers in the chat box. Okay. So now tell me, let me explain you this. What is a system? So see, a system is an arrangement in which all its components assemble work together according to a set of rules. So see, we will say systematic approach, which means they are following a set of rules or set of equipments which all are combined together, work together to perform an operation that you called as a system. So it can also be defined as a way of working, organizing or doing one or many tasks according to a fixed plan. Okay, I see a lot of replies here. Oh, thank you all for your answers. Okay. Yeah. So for example, let's take a time system. So clock is a time displaying system, right? Follow a set of rules to show time. If one of its parts fail, the clock will stop working. So we can say in a system, all its subcomponents depends on each other. This is what system is. So now, what are embedded systems? We are talking about system. Now what are embedded system? So an embedded system is a system that has software embedded into hardware, which makes a system dedicated for a specific task. So embedded means something which is attached or integrated to another thing. So it is a combination of hardware and software in which the software is embedded into hardware and it is designed to do a particular task. So the task has to be completed in a given time. This is the main constraint actually that you called as an embedded system. So an embedded system is a microcontroller or microprocessor based system. So it is not like a general purpose computers. These are the embedded systems which may work independently or attached to a larger system to work on a specific task. So let's see some examples, then you will get a clear idea about it, okay? So see this. So embedded system applications appear in every industry and sector today, right? Embedded devices and softwares play a crucial role actually, like functioning of cars, home appliances, medical devices and other equipment we use in our daily life. So if you look around you, you can actually see a lot of embedded system examples. Nowadays, a lot of things are being designed based on embedded system. So let's see some real life example. Okay, here see first GPS system. So this navigation system, right? So that uses satellites and receivers to synchronize data. So related to location, related to time and as well as velocity. So the receiver or device that receives the data. So the embedded GPS devices allow people to find their current locations and destinations easily. So nowadays GPS systems are generally used in cars, mobile phones. You can get to know more things, right? And then fitness tracker. So fitness trackers are wearable devices that can monitor your health and track activities like sleeping, running and walking. So these devices use embedded systems to collect data related to your heart rate, body temperature and the number of footsteps, which is further sent to servers like via WAN like LTE or GPRS. So fitness trackers are generally used for monitoring like personal activity, medical monitoring and sports training. And coming to this ATM, it is a computerized machine used in banking that communicate with a host bank computer over a network. And the bank computer verifies all the data entered by the users and stores all transactions. So while the embedded system in the ATM displays the transaction data and process inputs from the ATM keyboard. And there is a thing, home security system. This is the best example for embedded system. So home and as well as office security system contains a network of sensors, cameras, alarms and other embedded devices. So gather information about a building's interior and as well as exterior and use it to alert users. So we can also take like mobile embedded system like small portable embedded devices such as cell phones, laptops, digital cameras, smartwatches, calculators and so on. So now let's see main components of embedded system. So actually the embedded system mainly consists of three main components. What they are? First one is hardware, second one is software and third one is RTOS. So first let's talk about the hardware. So an embedded system uses a hardware platform to perform the operation. So the hardware of the embedded system is based around microprocessor and microcontroller. It has the elements such as input-output interface, memory, user interface and display unit. It is not a general purpose system, right? So you don't need to put every hardware to the system. Generally like the hardware components can be memory, power supply, processor, timers, input-output circuits, serial communication ports. And then coming to the software. So now let's talk about this software. So it only requires the hardware. It's just only required this hardware which is needed to perform that specific operation or application. So this application software allow the user to perform varieties of application to be run on an embedded. And then there is a main thing, RTOS, real-time operating system. So RTOS is another important component that is present in an embedded system. So when a system is finishing its task and send its service on time, then only we can set it as a real-time operating system, right? So RTOS, that are real-time operating systems, mainly it is doing the function of coordination between hardware and software. So the question arises in our mind that why we are going for a real-time operating system? Why? Because if you take the case of automatic washing machine, here there is a lot of importance to time, right? At this time interval, the washing machine should be completed, or within this time interval, the draining should be completed. So likewise, there is actually a lot of importance to time. If you take most of the embedded systems, time is actually a very critical thing. So if you miss the time limit or like the deadline, the functioning of the embedded system will be completely disturbed. Now the main difference between a real-time operating system and a non-real-time operating system is that in real-time operating system, they are giving more importance to deadline. If that deadline is missed, the performance of the system will be very much affected. So that's why we are going for RTOS. While in non-real operating system, we just neglect the time deadline. So now let's move to the next slide. See, characteristic of embedded system. Okay, so first one is perform specific task. So embedded system perform some specific functions or some task, specific task. And then is low cost. The price of an embedded system is not so expensive. And then there is a thing called time specific. So it performs the task within a certain time frame. And low power. It doesn't require much power to operate. And high efficiency. The efficiency level of embedded system is so high. Minimal user interface. So these systems require less user interface and easy to use. And then less human intervention. It requires no human intervention or very less human intervention. And then that is manufacturable. The majority of embedded systems are compact and affordable to manufacture. And they are based on the size and low complexity of the hardware. And then microprocessor and microcontroller. So it can be either microprocessor or microcontroller based. Both are integrated circuits and give the system compute power. Now let's see basic structure of embedded system. So this is the basic structure of embedded system. First one is sensor. So sensor helps you to measure the physical quantity and converts it to an electrical signal. And it also stores the measured quantity to the memory. So this signal can be read by an observer or like by an electronic instrument such as A to D converter, analog to digital converter. And then there is a thing called AD converter. So an analog to digital converter converts the analog signal sent by the sensor into a digital signal. It's called memory. So memory is used to store information. Embedded system majorly contains two memory cells. One is volatile and another one is non-volatile. So volatile memory stores data and computer programs that the CPU may need in real time, and it erases them once, like a user switches off the computer, like cache memory and RAM, which are the types of volatile memory. So on the other hand, there is a thing called non-volatile memory, which is static. So it remains in a computer even after a user switches it off. So this is the difference between volatile and non-volatile. And thing called processor and ASIC. ASIC means application specific integrated circuit. So processor which processes the data to measure the output and store it in the memory. So ASIC is nothing but an integrated chip designed for a specific purpose. For example, let's take a toy bear, okay? that contains a chip for talking purpose. So it handles the interface between that memory and microprocessor. Converter, which means digital to analog converter. So it converts the digital data fed by the processor to analog data. And then actuator. So actuator compare the actual output to memory stored output and choose the correct one. So the sensor reads the external inputs, then the converter, which is nothing but ADC, which makes the input readable to the processor, and the processor turns the information into useful output for the embedded system. Now let's move to the next slide, which is advantages and disadvantages of embedded system. So see, it is versatile because of smaller in size, right, and faster to load. It is easy to manage, low power consumption, low cost, dedicated to only one system, and it spends less resources. And there is some drawback, yes, high development cost. It's really difficult to upgrade, troubleshooting is difficult. If any problem occurs in the sense, you need to reset the settings. And larger time to market. So these are the advantages and disadvantages of embedded systems. So now let's move to the important topic, which is microprocessor versus microcontroller. So processor is the embedded system, right? It is the basic unit that takes input and produces an output after processing the data. For an embedded system designer, it is necessary to have the knowledge of both microprocessor and microcontrollers. So now let's talk about the microcontroller. So what is a microprocessor? What is a microprocessor first of all? A microprocessor is also called CPU. This is the main part of the computer which performs all the operations. So first thing is microprocessor is the brain of the computer. Everything is done by processor, just like a human brain, right? If our brain is dead in the sense, we can't do anything. Because brain is sending every information to other parts of the body. So the same way the processor is also called as brain of the computer. And then it is a single chip which is capable of processing data. It is a single chip which is present inside a computer. So inside a computer there is a motherboard. Inside a motherboard there is a single chip which is called microprocessor. And see, it controls all components in the computer. So in the computer we are having so many components like memory device, monitor, input-output device, USB ports and so on. So we connected these components externally to the computer. So these are all controlled by processor. And then it executes sequence of instructions. So whatever the data the user is giving, it will be executed in the sequence of instructions one by one. And at last it fetches, decodes and executes the instruction. So fetch means taking. So fetching the instruction from other devices or like other components of the computer. After that it's decoded, which means whatever we are giving is just English type language, right? Means C, C++, Java. So it's converted to assembly language, then into machine language. So machine language is nothing but binary language, which is zeros and ones. So at last it executes the instruction. Those who are facing with issues in WhatsApp link, please wait for few minutes. They will try to solve the issues. So please wait for few minutes. They will clear it and you can go for that link and try to join again, okay? So please be patient. Okay. So now, this is the structure of microprocessor. See, microprocessor typically consists of three parts. So inside a single chip, there is three things. What it is? Register, ALU, and timing and control circuit. So exactly what these three will perform. So first let's talk about register. Register is nothing but a temporary storage location, which means data will store temporarily, not permanently. Whenever the processor executes the data, it will erase. And then ALU, you already know. So it performs arithmetic and logical operations, like means all the mathematical calculations are done by ALU. And timing and control circuit. So it keeps all the other parts of the system. So whatever the parts of the system that is present outside chip, like memory, registers, ALU, input output devices, which working together in right time sequence. So whether they are performing operations in right timing or not, that will be checked by this timing and control circuit. Control circuit. So up to now, we have just seen what the things that are present inside the processor. And now let us see microprocessor connected with which components outside. So three things. One is input, output, and as well as memory. So first input, it is used to give input data to the microprocessor, and then there is a thing called output. It is used to provide the result. So whatever the result, it will be displaying on the screen or stored in the memory. And then there is a third thing called memory. Memory is used to store the data, and it is bidirectional. It acts as input to the processor as well as output to the processor. Suppose the processor want to do some operation, in the sense it fetches the data from the memory and perform the operation, and again it's stored in the memory. This is how it actually works. And now let's talk about microcontroller. Those who are keep asking for attendance link may ask one question: is the session is boring? You are not even listening the class. Why? Is the session is that much boring, or you not want to gaining some knowledge from here? Please wait until they provide you the attendance link. Until then, listen the class. Don't disturb the remaining peoples. Okay, so microcontroller. So it is an integrated electronic computing device that includes three major components on a single chip. That is microprocessor, memory, and input output ports. See, microcontroller is an integrated electronic computing device that includes three major things on a single chip: a whole microprocessor itself, memory, and input output port. So thank you all for a response. I have seen a lot of positive response. So thank you all. Okay. So see, this is the structure of microcontroller. So microprocessor unit means what? It consists of ALU, register, and timing and control unit. Control circuit. Whereas the microcontroller means the complete microprocessor is present inside. Along that, you are having memory, input output ports integrated in a single chip. That what we call microcontroller. And some devices are also supporting device. It also has supporting device. Those are timers, ADC, serial input output, and like other devices. Communication. This is not just an arrow mark. This is called common communication line. So these lines are called as buses. We can also call this communication lines as buses. So all the components connected with the help of buses. And a system bus is divided into three types, like address bus, data bus, and control bus. So what is the purpose of address bus? What is the purpose of data bus? What is the purpose of control bus? Have you ever heard about these communication line or buses in your class or in your college, somewhere? Please drop your replies in the chat box. Have you ever heard about these buses, communication lines? Have you? address bus, data bus and control bus? Okay, so now let me tell you that thing. You can drop the answers in the chat box. I will watch it in few minutes later, okay? Yeah. Okay, so I can able to see your reply like yes from the most people, okay. Those who don't have any idea about the sense, it's also okay. We can learn together, right? Okay, okay. Thank you all. So see, the purpose of the address bus is, it is used for where we have to get the data and where we have to put the data, that we have to know. Using that address bus, we can able to know where we have to get the data and where we have to put the data. And then the second thing is called data bus. So the data bus consists of what type of data is to be transferred from one component to another. And then there is a thing called third one, control bus. So control bus is used to control these data to transfer to that particular address. So these are the three things which is used for. Is it clear? So let me tell you again. Address bus is used for where we have to get the data and where we have to put the data. It will tell us. And data buses consist of what type of data is to be transferred from one component to another. And control bus is used to control these data to transfer to that particular address. So now, in a short line, what is a microcontroller? So see, a microcontroller consists of three main components that are integrated in a single chip. So the three main components that are present in a microcontroller are microprocessor, memory, input-output, and other devices like timer, ADC, serial input-output and other devices which are communicating using communication lines, which is nothing but buses. So this is all about microcontroller. So now are you able to see the difference between microprocessor and microcontroller? This is all about the microprocessor and microcontroller. Both are good in their own way. We can't tell like this is the best, this is the best. Both are best in their own way according to our need. So now let's see the difference between microprocessor and microcontroller. Then you will get a clear idea about it. So see, the first point is microprocessor is the heart of the computer system. Note this, heart of the computer system, and microcontroller is the heart of an embedded system. So it is only a processor. So you have to like memory and input-output components need to be connected externally. It doesn't have internal things like memory, input-output unit like microcontroller. But here it has a processor along with internal memory and input-output component. So memory and input-output has to be connected externally, right? So the circuit becomes absolutely large. And the cost of the entire system is also high. Here, memory and input-output are already present. So the internal circuit is also small and the cost of the entire system is also low. Here see, due to external components, the total power consumption is also high. Here, the external components are very low. So power consumption is also low here. And it is mainly used in personal computers. It is mainly used in like washing machine, MP3 players and like embedded systems. You can go for a lot of examples outside, right? And here, microprocessor has a smaller number of registers. So more operations are memory based. Here, it has more registers. So the programs are easy to write. And here see, this is von Neumann model based and controller is hardware model based. We will learn about that von Neumann hardware architecture in the later slide. So let me explain you that in the next slide, okay? So processor is von Neumann model based and controller is hardware architecture model based. So it has no RAM, no ROM, no input output units, timers and other peripheral on the chip. But here if you are taking, it has a CPU along with RAM, along with ROM, and also with other peripherals which are embedded on a single chip. So it is used for general purpose applications that allow you to handle lots of data. And here it is used for application specific system only. So this is all the difference about microprocessor and as well as microcontroller. Is it clear, everyone? Now I think you will, I hope you get an idea about what is microprocessor and what is microcontroller and the difference between these two things. Okay, so now let's talk about the architecture of embedded system. So see, typically embedded system mainly has two parts. One is embedded hardware and another one is embedded software. So embedded hardwares are based around microprocessors and microcontrollers and also include memory, a bus, input, output and controllers, whereas if you are taking embedded software, it includes like embedded operating systems, different applications and device drivers. So basically there are two types of embedded system architecture. So whatever the processor you are taking, whatever the microcontroller you are taking, the complete embedded system architecture categorized into two types. One is hardware architecture and another one is one human architecture. It is like architecture of the embedded system include sensor, ADC, DAC, memory, processor, actuator, etc. So let's see what it is. First, let's talk about one human architecture. Okay. So here is the explanation. So let me explain you. So whatever the data and the code that we want to store or we want to access in embedded system, that data and that code lies in the same memory block. See, I'm repeat this again. Whatever the data, whatever the code that we want to store or access in an embedded system, in the sense the data and the code lies in the same memory block. There is no separate memory block for data and code. It shares the same memory block. That is referred as a one human architecture. There are three major components that constitute this architecture, which are CPU, memory and input-output interface. I am talking about this. CPU, memory, input-output interface. These are the three things, majorly three main components of this architecture. So as I told earlier, data and instruction both reside in a single memory unit. Hence, a single set of buses is used by the CPU to access this memory. To access the memory, the CPU only uses the single set of buses. In this architecture, one data path or one data bus exists for both data and instruction. Whether the bus can be data bus or it can be a control bus or it can be a address bus, so that only one bus is used for both data and instruction. As a result, CPU can perform only one operation at a time. So that it is either fetching of data from memory or like performing read-write operations on data. So anything, any operation can be done at a time. This is called one human architecture. So if you are taking hardware architecture, see here the data and code like or instruction lies in a different memory block. There is a separate memory for code, I mean program or instruction, and there is a separate memory for data. That is referred as hardware architecture. So this means unlike one human architecture, here data memory and instruction memory is in separate format. But as here two separate memory units are used, thus exactly separate buses are also used for data transferring and instruction fetching. It has separate data bus like address lines, data lines, control lines as well as here. So as a conclusion, execution speed is very much faster than one human architecture. If you are comparing one human with hardware in the sense, the execution speed is very much faster. So this is all about one human architecture and as well as hardware architecture. So now let's move to the next thing, which is RISC and CISC architecture. So see, instruction set or instruction set architecture is the structure of the computer. So that provides commands to the computer to guide the computer for processing data manipulation. So what does instruction set consist of? So it consists of instructions, addressing modes, native data types, registers, interrupts, exception handling, and as well as memory architecture. So this instruction set architecture can be considered as the boundary between software and hardware. So classification of microcontrollers and microprocessors can be done based on the RISC and CISC instruction set architecture. So now let's talk about this in separate form. First, let us go to the RISC architecture. RISC means reduced instruction set computer architecture. So which means it is to make hardware simpler by using an instruction set like composed of a few basic steps for like a loading, evaluating and storing operations. So just like a load command will load the data and like a store command will store the data. So this microprocessor have fewer instructions. They have like a simpler circuits, which means they operate faster. Additionally, RISC microprocessor have more registers, use more RAM, and use a fixed number of clock cycles to execute just only one instruction. You can also call this as load or store architecture. So where it is used? It is used in like portable devices like Apple iPods, smartphones, tablets and so on. So now see CISC architecture, which means complex instruction set computer architecture. So in CISC architecture, a single instruction will do all operations like multiplication command will do stuff like loading data, evaluating and storing it. Hence it's complex, right? The name itself, it will tell like complex instruction set computer. Reduced instruction set computer and complex instruction set computer. Okay. So this CISC based microprocessor are more complex and slower compared to RISC. It uses only little RAM, it have more transistors, it have fewer registers, have like numerous clock cycle for each instruction and have a variety of addressing mode. So where it is used, it is mostly used in like laptops and PCs. So now let's see the characteristic of RISC and CISC. So in RISC, it consists of simple instruction. It consists of large number of instructions. It utilizes only simple addressing modes and it has variety of addressing modes. And here it consists large number of registers. It only consists smaller number of registers. See, it requires only one clock cycle for execution time, but in CISC, it requires several clock cycles for just only one instruction to execute. That's why it's complex compared to this RISC. So this is all about the characteristic of RISC and CISC. So now I will introduce you some other thing. So see, let's see some reel for demo reel using Arduino. Okay. So I will play you this video. You can go for it. So see, this is the attendance system using RFID. We are using Arduino Uno, I2C LCD and as well as EM80 reader module. This is some sample reels for this entire 21 days masterclass. Yeah, like this we are going to do some mini projects, or we are going to do projects like this in this entire 21 days masterclass. So for today and tomorrow we just go for basic things. So today we have already talked about the introduction to embedded system. In tomorrow's class we go for introduction to Arduino, and from third day itself we can go get into the actual topics. Okay. So now let me tell you the important thing. So this is the right time to convert this masterclass into the certified internship. So see, in this 1 month internship of embedded systems on Arduino, you can get 90 days access to complete records of the session, 30 days internship certificate, and you can download all the 30 days class presentation files, and 8+ project source codes for download, and 6+ Zoom classes for every week, like mastermind sessions. You can interact with your mentor, you can clear your queries, clear your doubts in that session, and there is a group chat for those internship members, and you will get access to Pantech community and also career guidance session. So here we are going to see some projects which are included in this internship, which are soil moisture control, smart street light monitoring, water quality monitoring, smart parking using Arduino, health monitoring, smart circuit breaker using Arduino, and ATM security using Arduino, vehicle speed control, and as well as surveillance system using Arduino. So this 1 month internship just for $699. Use this payment link to pay your money. And another thing, if you want to do internship for 3 months or internship, this is the lineup. You can get Arduino, Raspberry Pi, Internet of Things, and as well as PCB design just for $1299. So use this chance and get your 3 months internship. And in this 3-month internship, you will get 360 days access to complete records of the session, 3-month internship certificate plus 3 individual certificate, and you can download 30 days class presentation files. You will get 18+ project source code for download, and 12+ Zoom classes for every week, like mastermind session, and you will get the access to the VIP WhatsApp group, and you can get the access to Pantech community and as well as career guidance session. So this 3-month internship on embedded system is for $1299. Use this registration link to payment. And so tomorrow class we are going to talk about introduction to Arduino. So happy learning. Thank you all. Use this contact number to clear your queries and doubt to the coordinator. So this is all about the today's session. Thank you all. Have a very nice day. Let's catch up at the tomorrow's session with different topic. Wait for a few minutes, attendance link will be provided. Yeah. Now the class is only for 45 minutes. Please wait for a few minutes. They will provide you the attendance link. You can go for it. Yeah, attendance link have been provided. Make use of it. Thank you all. Have a very nice day. Attendance link have provided. Go and check it out.